Why choose regression for a machine learning problem? Imagine trying to predict how much a house will sell for based on its size, location, and features, or estimating how many products a store will sell next month. These are examples of problems where the answer is a number, not a category. That's where regression comes into play. Regression is a simple yet powerful technique in machine learning used when the goal is to predict a continuous value. Unlike classification, which sorts data into groups or labels, regression estimates quantities that can change over a range. Think of it as drawing a line or curve that best fits your data points, helping you understand how different factors influence the outcome. At its core, regression looks at the relationship between one or more input features and a target value. For example, if you want to predict house prices, the input features could be the size of the house, the number of bedrooms, and the neighborhood. The target is the price. Linear regression, the most basic form, finds a straight line that best describes how these features relate to the price. But there are many other types of regression that can handle more complex patterns, like polynomial regression or regression with splines. People often choose regression because it directly answers questions involving numbers. For instance, predicting sales based on advertising spend, estimating patient risk scores from medical data, or forecasting temperatures. These are common in finance, healthcare, marketing, and many other fields where knowing the exact amount matters. Another reason to pick regression is how easy it is to understand and explain. Linear regression models show which factors influence the outcome and by how much. This transparency makes it easier to communicate results to people who aren't data scientists. It also helps identify if any biases or errors are present, supporting responsible AI use. Regression models tend to perform well when the relationship between inputs and output is mostly linear. They can handle some noise or outliers, making them robust in real-world situations. When relationships are more complicated, other methods like decision trees or neural networks might be better. But starting with regression gives you a clear foundation to understand how data relates to outcomes. In the broader context of machine learning, regression is a great entry point. It shows how machines learn from data to make predictions, which is the core idea behind many advanced tools like ChatGPT, DALL-E, and Midjourney. These models learn patterns from data to generate text, images, or media, building on the same principles. Many AI tools and productivity plugins also use regression-like reasoning behind the scenes. For example, a plugin that predicts project completion times might analyze past data to estimate how long similar tasks will take. Knowing how regression works helps you understand how these tools generate their results and how reliable they are. From an ethical standpoint, regression's transparency is a big plus. Because the models are straightforward, it's easier to spot biases or unfair influences in the data. This makes it possible to build AI systems that are fairer and more accountable. To sum up, regression is a go-to choice when you need to predict a number, want a clear explanation of how your model works, and your data relationships are fairly simple. It's a practical, understandable, and widely used method that connects basic statistics with the more advanced AI systems we see today.